And then you should have this PowerPoint on your Moodle in Start 401 section. So last class, we looked into some of these slides where we discussed about t-test, t-score, and the test of significance threshold, right? So p-value, and it's 0.05 threshold. If the threshold is less than 0.05, then you say that the groups are significantly different. And if the threshold is more than 0.05, you say that they are relatively same, right? So there is not much difference. Then we also looked into types of t-test. So it can be like an independent t-test, which compares the means of two groups, right? So the keyword here is number of groups. So if you have more than two groups, then or if you have two groups, then it's the independent test. If you have the same group, right? So same group, say at different time points, then it's the paired test, paired t-test, right? So as the name suggests, paired is like same group but just at different time points, pair, right? Independent is two groups are different, so it's independent. And the last one is the it's just a single group, but comparing the single group with the some standard value, some reference like mean or some reference variance, right? So that's called your one sample t-test, right? So significance of threshold, and this threshold here is flexible, right? So normally this is like a standard thing to have a value of 0.05, but obviously some people consider it to be more stringent, right? So they may have a p-value threshold of like 0.01 or 0.04, right? Less than 0.05. Or some people are they have a high threshold. It can be like 0.1 or 0.06 or 0.09, right? So this is a flexible threshold. It depends upon obviously your data, like what data do you have. And there are other things which can be considered while you apply this threshold, but standard and acceptable number is 0.05. And this number says that the differences are not by chance, right? So there is some significant difference or variation between two groups. And if the value is more than 0.05, then you say that it was just like by chance, right? Just there does not seem to be any feature differences. So that's the three types of t-test. And we also looked into some of the examples, right? So normally a pair t-test, right? So say you have like a COVID patients, and you want to compare the vaccines, right? So vaccines effect at time point 0, time point 1, time point 2, time point 3, right? Time points can be, say, number of days. So what happens when a person takes a COVID vaccine at today, and then tomorrow, then day after tomorrow, then after a week, then after a month, right? So to do this analysis or the comparisons, mostly the popular test would be a pair t-test, because it's the same COVID subject. You are just testing that subject at different time points, right? So it's a popular test, especially in clinical trials. And so I want you to know some examples of this test, right? So when would you use a pair t-test? So as I just said, that when you say want to do a clinical trial testing and you want to compare same subject at different time points, or you want to compare the blood pressure measurements at different time points, or you want to compare two tests but for the same person, before and after training, right? So same person, the same group is the keyword here. So those are some examples of pair t-test. And if you are a biology student, right, biology major student, you should be, or perhaps you must have used this test before, right? Knowingly or unknowingly. So normally when you say like a t-test in biology, it's mostly a pair t-test, right? Because you are comparing the same group. Okay. So then we will look into the t-test measure. So this is a new slide today, right? So this slide says, what does a t-test measure? So a t-test measures a difference between groups means divided by pooled standard error of two groups, right? So it looks into means, right? So as I said before, you're comparing means, and you compare means by dividing it by standard error, right? So there is a difference between a standard error and standard deviation, right? Standard deviation and standard error. So in the next slides, I will explain you what is standard error, what is standard deviation. But a t-test measures the difference between group means, right? Means is important because you are just comparing two means, and additionally you are dividing those means by standard error, pooled standard error. Okay, so in this way it calculates a number illustrating the magnitude of difference between two group means, and it estimates the likelihood that this difference exists purely by chance, where you look at the p-value threshold, right? So once you do your t-test, you will get a p-value, and based upon the p-value, you will determine if the difference is by chance or the difference is a real difference, right? If the p-value is less than 0.05. So we will use some functions in R, right? So function for t-test, and we'll use that function to get the p-value, right? So p-value is the output which comes out of your t-test, and based upon this p-value, you get to know if there is a difference or not. A t-test is a statistical test that compares means, and it is used for testing the hypotheses. Null hypothesis means that the difference in the group means is 0, and the alternate hypothesis means that the means is different from 0. Okay, so I'm sure you know about a hypothesis, right? So a hypothesis is just an assumption, and a null hypothesis and alternate hypothesis, right? These are two types of hypotheses which you need to develop before you do testing, right? So a null, as the name suggests, null is none, right? So no difference. Null means no, none, right? So no difference. So a null hypothesis is that there is no difference, And the alternate hypothesis means that there is a difference, right? So as the name suggests, alternate is there is a difference. Null is there is no difference. So before performing a t-test, you need to make your null hypothesis and you need to make your alternate hypothesis, right? So for example, if I am doing the COVID vaccine testing, right? So I'm testing a COVID vaccine efficiency on subjects. So subject 1 gets the COVID vaccine at time point 0. Then they get then you observe the changes in symptoms, say after 1 hour, after 24 hours, after 2 days, after 3 days, after 4 days, after 5 days, right? And you observe this for a week, for 1 week. And then you do the same thing for subject 2. Then you do the same thing for subject 3, subject 4, subject 5, subject n, right? So the null hypothesis in this case would be there would be no effect of vaccine on any of these subjects, right? So say subject is just having symptoms at day 0, then they would continue to have symptoms at day 0, at 1, at 2, at 4, at 5, at 6, at 5, 7 for a week, right? Same symptoms, no changes, no decrease in symptoms. Whereas the alternate hypothesis would be that there is a difference, that subject probably is recovering, right? So the symptoms are getting lesser, right? Say day 0, they had the intensity of say 10 for those symptoms. Then at time point 1, which is say 1 hour, the symptoms were decreased intensity. Then after 1 day, the symptoms were decreased intensity. Then after 2 days, they were with significantly less. After 1 week, they were probably no more symptoms, right? So this is an example of hypotheses, null hypothesis, and alternate hypothesis, right? So a null hypothesis means that there is no changes, 0 changes. Everything is as it was before the study. And the alternate would be that there are some changes. The changes can be positive changes or they can be negative changes, right? So it's not necessary that vaccine would going to decrease the symptoms, but it may also increase the symptoms, right? Like side effects, adverse effects, right? Or it may also have no changes, right? So no changes. So there can be 3 outcomes of alternate hypotheses. First is like it can increase, right? The symptoms can increase, get worse, which are the adverse side effects, or it can decrease, which is good because vaccine is working, or it can have no effect, just as null hypothesis, right? So any questions so far? Do you understand what is the hypothesis, null hypothesis, and alternate hypothesis? Any questions so far? Good. So I would be interested to ask you these questions, right? So what does t-test measure? So t-test measures mean divided by standard error. Then what is a hypothesis? Example, what is a null hypothesis? What is an alternate hypothesis? Right? So so that's your t-test. And we would be using R for the t-test function. And from the t-test function, we will be getting a p-value. So based upon that p-value, you can check if there is a difference or no difference. right? So I have a pair t-test example here. So these are some lines of code which can be used in R to calculate your pair t-test, right? Now this is very specific to pair t-test, right? So this function t.test is pair t-test. But if you want to use independent sample t-test, or if you want to use the third type of t-test, right? One sample t-test, then you may have to use a different function. But this function which I have mentioned in this slide, number 12, is very specific to pair t-test. So once you run this function, you will get a p-value. And the p-value can range like anywhere between like 0 to 0.1 and above, right? So the next thing which I want to do today is I want to test your R software, right? If you are not installed, you want to get that installed. So can you test if you have this R version installed on your computer? R 4.1.2. So let me know if you, I'm sure like some of you were in my last class last semester. So you must have R software installed. So if you have that installed, open your R console and check your R version from the first line of your R console and post your R version in your chat box.
Dr. Pawar, I was in your class, so do you want us to look at the one for 4.1 or 4.21?
4.2 is the most recent. I have 4.1, so anything between 4.1 and 4.2. Okay, Jalen, are you there?
Yes,
What's your R version?
I have it since the last class. Oh, it's whatever we downloaded last class, the newer version.
Are you downloading it now?
I already have it downloaded.
Yeah, are you installing it now? Okay. So what we should do is let me check my Git report, Git followers, if I can see your name. Okay, so I see your names. So what we want to test is we want to test your R program, right? So open a new R document in your R from your R and hashtag your test, hashtag write your name, date, right? Okay, so make a new R document and type in these two comments. Save this R document somewhere on your desktop as first underscore R program, right? This is the name of your file and save it. Save the R script. Okay. And go back to your Git. Go to the repository which you have for this class. For me, I have made a repository for this class as I think it's start 341. Sorry, start 401. Right here. And from your repository, so if you don't have a repository, make a repository called start 401 fall 2022. Right? So to make a repository, what you do is you just to click on the right side of your Git account, and there's an option called new repository. So in the new repository, you just have to give your repository name as start 401 fall 2022. Okay, repository name, and just keep all the options default as public, and then you should be able to create a repository here. Once you create your repository, then you can go back to that repository from your profile here, your repositories, and go back to the repository called start 401 fall 2022, which you just created. Okay, so let me know when you are in this repository or if you have any questions. So this is testing your R and testing your Git upload. So once you are in this repository, which you have created for this class, you can add a file, right? So you see option here, add file, and you can upload files. Upload files, and you can just drop in your first R program file here. And once you drop your R file here, you can commit changes. And then you should have your first R file in this repository. And this is the file which I need to check, right? This is the Git test author. So I should be able to see your R files in your start 401 fall 2022 repository from your Git profile. Okay, so this is what I want to check. And please give me your Git profile name in the chat box so that I can check your repository. Okay, I just got two of you.
I follow you, so mine should be visible.
Hmm. What's your ID?
B Howard 06.
Okay, and Timothy?
I think I saw his right above my name. Let me think.
It's Timothy 02. I just submitted mine as well.
Okay, got it. Okay, so I have all of you, and I feel like your upload seems to be working fine. And your R is also looking good. So one thing you must have noticed is your R files may end with .r document, right? So .r, and my would be say .rd document, right? So if I look at my R program here, it's .rd, right? You see the difference here, .rd, and yours is .r. Now this is because there are some differences on creating these different documents, right? So if I do a new document, right, there are two options. You can create a new document, or you can create a new RD document. So I have created a new RD document. So the difference is this this document is just .r format, right? This document, when I create new document, it's just .r format, and new RD document is a RD format. And there is slight difference between these two formats. So, an RD document is very specific to R, right? As the name suggests, RD is R document. R is for R, and D is for document. RD is R specific document, right? And new document is not R specific. You can change this format to like a text format. You can change it to a Word format. You can change this document format to a to an say text edit format, notepad format, right? RTF format, right? So you can change the formats for new document, which is fine, right? Which you can do it, and you should not have any issues of converting this document. But if you have an RD document, that's a very specific R format document. So if you try to convert the RD document to say RTF format or to a text format, then it may mess up the formatting because it's an R specific document, right? So, so if you want to have a document which is very specific to R, right? And you know that you are not going to do that conversion, right? So you should make an RD document, okay? And that would be very specific to our language, right? And but if you want to be flexible, right? So if you want to have a document which is R and then probably convert that to a different format in future, then you should just make a new document, right? A not non-R specific document. That's a very simple difference. I prefer to make a new document, right? Because I may change the formatting feature. So I need to have that flexibility in the document format. So I usually make a new document. but I wanted to show you the difference between an RD document and a new document, right? So most of you, I guess you have created an R document, which is a flexible format. I have created a RD document, right? Which is a R specific document. That's the only difference. It's not a bigger deal, but then, but then if you down the line, like if you are not able to do a conversion of RD document, it's because it's R specific format document, right? So that's the difference. And in this class, we will just try to make new documents, right? New documents. So there is another thing called as workspace, right? So if I go back to my R console, this is where you'll be running your functions, R console, right? So Python should have a Python compiler or console. Ruby has a Ruby console, R has a R console, Java has a Java console. So console is where you run your functions. Now a workspace or a session, right? So you can save your workspace, save your session. So whatever functions you run on console can be saved, right? Just as your documents, but it takes some memory, right? So if you're running a function and you have read in some data, right? So your data is like a 1 GB of data, right? So with rows and columns, some information from your memory, right? So you have read in your data, you have run, say, t-test on your data, and then you have some output from your data, right? So that would be on your console runtime, right? So you can save this runtime. You can save the read in and your output and your analysis, but then it will take up some memory from your computer, right? So you save all of these sessions. It will take significant amount of memory from your computer, which we don't want, right? So I usually don't save my sessions because you can always rerun it, right? Rerun it and then recreate the same output. Unless you don't want to do it, right? Unless you don't want to recreate it, you can save it, right? But normally, the data sets which I work with are not that big, at least for the class. It may be big for my project, right? Project analysis, which I may have to like run it once, and then once it's done, then pretty much I'm done with the analysis, right? But for classes, we don't save. So for example, if I try to close this console, right? So just exit the R program, then it will give me an option, save workspace image or save the session. Here, I just say don't save, right? You don't save it. You can save it and it will save everything, all the functions which you have ran, all the data sets which you have read, all the output which you have received, right, from your analysis. And then it will give you an option to save it. But for this class, you don't save, right? So don't save. And then you exit your R program, but you still see the R program saved, right? Because you have saved the R document somewhere. Okay, any questions? Any confusion, error? So I feel like your R and Git is working fine. So so we will be running your t-test analysis and your second R program, right? Second document you'll be uploading on this repository here, so that I should have access to your second R program, which should have your t-test function. Okay. All right. So next class we will be testing this code here, right? So you'll be testing some dummy data. So this is your dummy data for two variables called X and Y. And then we will be using a t-test function to see if there is a difference between variable X and between variable Y by a function t.test. Okay. All right. So that's it. I guess if you don't have questions, we are done. I'll see you next class. with the t-test function.
Hey, I don't have a question about this class, but it's about your other class, the intro to I think like oriented programming. Like, is that in the classroom?
Which
I know it's the computer science. Hold on, let me get the actual number.
which class? Is it the programming or is it the lab?
The programming.
Yeah,
That was
the programming we are meeting on Tuesday and Thursday, right? In this MSRC 131.
oh, okay.
Yeah, but we are not meeting tomorrow. You were there yesterday, right?
No, because I didn't know that it was actually there. Okay, but not tomorrow.
I saw you yesterday. You were not in the class yesterday?
No, not me.
Okay, let me see who was there. Yeah, I think I saw probably. Yeah, you are not there, right? So we meet in class in the research science building class 131, and
Okay.
tomorrow we don't have a class. So we will be meeting on next week, Tuesday, same time,
Okay.
right? Is that the question?
Yeah, that's it. Thank you.
Okay, I'll see you on Tuesday.
All right.
Bye.